When we're using combinations, we can actually figure out probabilities and combinations based on Pascal's triangle. So Pascal's triangle, each row is determined by a different combination. But before we talk about that, first I want to actually show you Pascal's triangle and how it was actually formed. So the first, actually the row 0 is 1. Row 1 is 1 and 1. Row 2 is 1, 2, 1. And to kind of give you an idea of how they actually form this, you will always have on the left and right outside numbers a 1. Then the middle numbers are made up with by the row above it. So 1 plus 1 gives us 2. So now when we look at row 3, again, the 1 and 1 are on the left and the right. 1 plus 2 gives us 3. And you can see that this is listed twice. So this pattern keeps going on and on and on and on and on. Okay, so I only went up to row 5, but you guys can see how this works. So 1 and 3 gives me 4, 3 plus 3 gives me 6, 3 plus 1 gives me 4. 1 plus 4 gives me 5, 4 plus 6 gives me 10, 6 plus 4 gives me 10, 4 plus 1 gives me 5. And this pattern is just going to keep repeating itself. So the next row, if I'm looking at it this way, I know is going to be 1, 6, 15, 20, 15, 6, 1. And that's because we're just adding those numbers together in order to get the next row. So say for instance, though, they ask you for what are the numbers in the 11th row. This is where you might not want to go through and, complete Pascal's triangle until row 11. This is where combinations actually come into play. So let's say, I'm going to delete this. Sorry, it's kind of in my way. Let's say that I want to look at row 5, and I didn't have it listed out. So row 5 actually is in the form of 5 NCR0, 5 NCR1, 5 NCR2, 5 NCR3, 5 NCR4, and 5 NCR5. So if you notice here, 5 NCR0 gives us 1. 5 NCR1 gives us the 5. 5 NCR2 gives us the 10. 5 NCR3 gives us 10. 5 NCR4 gives us 5. 5 NCR5 gives us 5. So if I wanted the 11th term, I can use combinations in order to find that 11th term rather than listing them all out. That's the neat thing about Pascal's triangle. So you are actually using combinations in order to find your different row number. There are a couple other properties that we need to talk about here. If you notice, Pascal's triangle is symmetrical. So for instance, if I look at each row, it does get a split and I can reflect it onto the other side. So for instance, it's 1, 3, 3, 1. 1, 4, 6, 4, 1. The numbers repeat itself. The actual split, you guys can see, is symmetrical right through there. We know it's symmetrical based on that. The other property, okay, so properties. We've talked about a couple of the properties actually using the 5 NCR0 and all of that good stuff and all the all the first terms and last terms are 1. Those are 2 actual properties. But properties, each row is symmetrical. So that's another property. Another property, the sum of the terms in a row. So like if I wanted to add up all of row 4, it's actually 2 to the nth. So the sum of a row is 2 to the nth power. That's actually pretty cool when you think about it, that 1 plus 4 plus 6 plus 4 plus 1 is going to give me 2 to the 4th power. And if I add up 1 plus 5 plus 10 plus 10 plus 5 plus 1, that's going to give me 2 to the 5th power. That's pretty cool when you think about it. But that's just something, those are just properties that are part of Pascal's triangle. We're just going to be looking at, you know, how do you use Pascal's triangle? How do you look at Pascal's triangle? How do you find different terms and elements within Pascal's triangle? The next video will actually be using Pascal's triangle in order to talk about different probabilities and how they're all derived from this.